So, we're still working on Chapter 2 in animal behavior, and we'll look how robotics can be bio-inspired with everything they can find in nature. And what we want to accomplish is that we see what is the relationship in how you behave, in how you control a robot, and what you can learn from the animal kingdom. And we've seen how you can do that by, say, the wiring in neuroscience. And we're now looking on a higher level how you can learn from psychology with all the sort of behaviors that you can see in humans. And on the end, so we also have some clip about some bio-inspired robots. So, psychology, there with it we have it's quite a long history. It started with that a lot of the research in psychology was inspired by everything that happened in the physical discoveries that were started in the beginning of the 20th century. And that it's part that they learned a lot about electricity, about heat, etc. So they learned to quantify all those different new quantities that they found, and they starting to see what happens to the human body to that. One example of that is, for instance, in the beginning of the 20th century, also the vibrators were started as medical devices to reduce stress, and they found out that it really helped. Much later on, you get the chemical revolution, and they start to think about ways to influence the psyche with pills. But at that time, we were really thinking about how, with moving with objects and with electricity, you could change the psyche. Okay, so we will make a short history trip to all the different trends you could find in psychology and how they influenced robotics later on. So it started with physics in the beginning of the 20th century, and partly what they found out that if you give somebody a stimulus, that in some cases you have a linear reaction. So if you put a needle in a hand, it's how harder you push, how more pain you get. But some stimulants that you give as a lot of hard noise or a lot of light gets, say, less painful if you apply really a lot of more, but other ones really get far more painful as you add it, as for instance heat. So they did a lot of experiments there and find out how people react to different stimuli. And that's responded in behaviorism, where we see that if you give a certain stimulus, that you also get a certain response, so that you can also train animals, and even in this case babies, what to expect. And you could even combine different stimuli, that you get the same response by subjugating that stimulus for another stimulus. So the most important, well-known experiment there is the Pavlov, that you train a dog that it gets foods when a bell rings, and that it already starts dripping with it from its mouth because it hears a bell and has learned that food will be imminent. Now, that's quite simple, and we found out that not everything was that much directly related to the stimuli, and that you can make far more complex networks with different percepts and different consideration and different concepts, and that you can make a much more complex behavior what's going on in the brain. And there were a lot of experiments that were done, for instance, with monkeys, where you started to train them to grab, for instance, bananas by packing different boxes under it. But it was also that you learn to train dogs not in a single way, but first priming them, learning them to sit, and after that sit to give a leg, so that you train in 2 steps. And that's something also is now currently reinvented in reinforcement learning. There you also see if you have a lot of parameters, it has no sense to start training on everything, because the chance that they by luck find a behavior that gives a reward, that's not they really have to do brute force learning. But if you start training with simple tasks and make it more and more complex, then with it you can train far more complex behavior. Later on, they find out that you only learn in the right setting. So you first have to make sure that everything, all the preconditions for learning are fulfilled. In most of the experiments, that is done implicitly. But if you not give, you see that it's not learned. So at the moment that you give all those opportunities, then you can see that there is an affordance, and that the agent is willing to act because on all preconditions are fulfilled. So first you have to have attention, and only when you have the attention, then you start seeing things and then start reacting things and building up a sort of world model. So then we skip already to the second part of the 20th century, where you have cognitive psychology. There you would expect that a lot is inspired by the brain, and it was, but it was also inspired by the upcoming models of the computer. So they start up building long-term, short-term memories, and really not only putting the world models conceptually, but also really as models inside the computer. And there they started to think about how you build up long-term memory, but also how you start to forget things. And because the memory in that time, computers were quite limited, thinking about what you want to remember and how long you want to remember it, and how to forget was quite important. What you also see, say in the beginning of the 20th century, physics was really important because a lot was happening there. So they start building models about transducers and how you put heat into pain with that sort of models. in the 70s, 80s, the computers starting to work, and they start to think about the human brain as a computer with a hard disk where it stored its memory. So that shows how the bio-inspired robotics was inspired by different psychological theories, and in the next session we will look to etiology.